to start with the trigonometrical identities here. So this chapter is very important for the point of ICSE 10th examinations. So we have to know the three important identities. So let me write the first identities here. The first identity is sin square theta plus cos square theta equal to 1. This is the first identity of the trigonometric identities. So we can also write the sin square theta is also equal to 1 minus cos square theta. 1 minus cos square theta. So sometimes in the problems we need to apply sin square theta is equal to 1 minus cos square theta. So we need to know about this very well. Or sometimes cos square theta is also equal to 1 minus sin square theta. So this also sometimes in the problems we need to apply. Cos square theta is nothing but 1 minus sin square theta. We need to apply in the problems. So this is the first identity. The second identity is 1 plus tan square theta equal to secant square theta. This is the second very important identity. See, sin square theta plus cos square theta is equal to 1. We can also write secant square theta minus tan square theta is also equal to 1. So you can observe sometimes we need sin square theta plus cos square theta is also equal to 1, and sometimes we need secant square theta minus tan square theta equal to 1. It depends on the problems. When we solve the problems, you will be coming to know about it. Or sometimes when we solve the sums, tan square theta is also equal to secant square theta minus 1. See, we need to use this also sometimes in the problems. So please be clear with this, all the three. And the third very important identity, it is 1 plus cot square theta. Cot square theta is equal to cosecant square theta. Cosecant square theta. This also, we can also write this as cosecant square theta minus cot square theta. It is equal to 1. See, 1 can be written in three different ways. Sin square theta plus cos square theta is also equal to 1. Secant square theta minus tan square theta is also equal to 1. Cosecant square theta minus cot square theta is also equal to 1. So you can just observe this can be written in three ways. So 1 can be written in three different ways. So this is also very useful for you when you are solving the sums. So we can sometimes we need this cot square theta is equal to cosecant square theta minus 1. So cot square theta, we need to use this in the problems. While using this, we can solve the problems very faster. So these are the three important identities, trigonometrical identities. Along with this, students, you people have to learn algebraic identities also, which you already learned in your what you call it as higher classes. You have the lower classes you already learned. So let us recall that algebraic identities. Algebraic identities. So what is the algebraic identities? In this first one is a plus b whole square, a square plus 2ab plus b square. This is the first identity. And second one is a minus b whole square equal to a square minus 2ab plus b square. These identities which you learned in your lower classes. It's not something new here. And the third one is a square minus b square equal to a plus b into a minus b. The fourth one is very important. We will be using in the problems, the trigonometrical problems. No, we are going to use this. What is that? Very interesting is a plus b whole square plus a minus b whole square is also equal to twice of a square plus b square. Twice of a square plus b square. And the fifth one is a plus b whole square minus a minus b whole square. It is also equal to 4ab. See, children, these algebraic identities is equally important along with the trigonometrical identities. Along with this, you should always know this very well. Still one more is there, two more is there, It is AQ plus BQ. AQ plus BQ. It is A plus B into A square minus AB plus B square. AQ plus BQ. Sometimes we have to use this algebraic identity in trigonometric identity. So children, you have to be very clear with the identities also. The seventh one, AQ minus BQ equal to A minus B into A square plus AB plus B square. So these 7 algebraic identities are very important while solving in the trigonometrical problems here. So we are going to start solving the sums. Children, let us start solving the problems on this trigonometrical identities. Let me prove the following identities. The first problem I am taking here to prove that secant a minus 1 by secant a plus 1 is equal to 1 minus cos a by 1 plus cos a. We need to prove this. Children, you can take left hand side is equal to right hand side, or you can prove right hand side is equal to left hand side. So today, let me prove by taking left hand side and prove the right hand side. So LHS, left hand side, secant A minus 1 by secant A plus 1. I am taking the left hand side, children. So all of you should be very clear about the reciprocal relations. That's very important. Reciprocal relations for secant A. See, reciprocal relations for secant A is equal to 1 by cos A. This relation you should know very well, children, because secant A means it should be written as 1 by cos A. That is, and you should also observe the RHS also. So you can see RHS is in terms of cos only. So you should be able to understand secant A should be written as 1 by cos A. So I am writing here 1 by cos A minus 1. The same thing I am going to write in denominator also, 1 by cos A plus 1. It's a very simple, it is very simple, so that you will be able to understand that the secant A is 1 by cos A. Now when you see 1 by cos A minus 1, you should understand whenever the minus or plus comes, we should take LCM. That's a concept is very important, which you people have learned in your lower classes. You just have to recall that concept. That's a cos A. Cos A is actually the LCM. So you know that when you take LCM, you should write cos A here. If you all remember that concept here, cos A will get cancelled. What will be left here, children? 1 minus, and you know 1 into cos A is again, it will be written as 1 minus cos A. So this is the concept of LCM, taking LCM here cos A and writing as 1 minus cos A by cos A. The same thing I am going to follow in the denominator also, because plus sign is there in the middle. So definitely I should take LCM. So here also LCM is cos A. So you are going to get 1 plus cos A. The same concept, what I explained you in the numerator, the same thing comes in the denominator also. So cos A will get cancelled. How it get cancelled, children? It is by taking reciprocal. When you take reciprocal, cos A will go to numerator and 1 plus cos A will come to denominator. That's the meaning of reciprocal. So cos A will get cancelled. So you are going to get, that is 1 minus cos A by 1 plus cos A. Children, you can see very clearly it is RHS. We are getting RHS, right hand side. And that is nothing but LHS is equal to RHS. So this is how, children, you are going to prove that by taking the left hand side and proving the right hand side. Children, you can also take right hand side. Instead of writing cos A, you have to write as 1 by secant A. That also the way, taking RHS and proving the LHS. So both the ways you can prove this concept so easily. This is a very simple problem I have done for all of you. First problem is, students, let us take the second problem, that is 1 by tan A plus cot A equal to cos A into sin A. See children, in the last problem I took reciprocal relations and I solved the first problem. In this second problem, let me take the quotient relations. So you may ask me, what is this quotient relations and what is this reciprocal relations? Just now I explained you. Quotient relations means, see, tan A can be written as sin A by cos A. This is called as a quotient relation. And cot A can be written as cos A by sin A. I am writing this tan and cot A in terms of sin and cos. So what is the reason? I am taking left hand side and putting the right hand side. See, when I take the left hand side, I should always keep in my mind what is there in the RHS, right hand side, cos and sin A. So I have to convert this tan and cot A in terms of sin and cos. So that is the reason this is called as quotient relations. Quotient means like sin A by cos A. That's the meaning of quotient relations. So now let me just take the left hand side LHS. That is 1 by tan A plus cot A. I will take the left hand side. That is equal to 1 by tan A is sin A by cos A. Sin A by cos A. Plus cot A is cos A by sin A. I have just taken this tan A as sin A by cos A and cot A as cos A by sin A. So after this, you should understand again, you have to go back to the next step is that since plus sign is there, we should take the LCM. So what is the LCM? All of you should be knowing very well about this. The LCM is cos A into sin A. That is the LCM, cos A into sin A. So you should know that LCM properly. Sin A into sin A is sin square A. I am just taking the LCM concept, children. So you should be knowing sin A into sin A is sin square A. Cos A into cos A is cos square A. So this is a very important thing you should understand, children, that we have taken that 1 by sin square A plus cos square A by cos A into sin A. Now you have to go back to the identity, trigonometrical identity, which you should be remembering, all of you. Sin square A plus cos square A is 1. That is very, very important. That you should learn very well. That is equal to 1 divided by, I am just writing sin square A plus cos square A as 1. 1 by cos A into sin A. Cos A into sin A. I am writing as it is. This is a numerator part and this is the denominator part. That you be very clear about this. After this you should take reciprocal. As I already explained, the reciprocal means the numerator will come to denominator, denominator will come to numerator. So that is nothing but cos A into sin A. That is what your RHS, right hand side. So therefore LHS equal to RHS. So we have proved LHS equal to RHS. You can see this problem is based on by taking tan A as sin A by cos A and cot A as cos A by sin A, and we are able to prove very easily. So children, you have to be very clear with the concepts. That's very important. So today we are going to take the next third problem. The third problem is sin to the power of 4a minus cos to the power of 4a is equal to sin square a minus 1. So that is the third problem we are taking here. So this we need to observe very carefully. We cannot simply take the sum and so keep on solving. So let us take the left hand side and prove the right hand side. As it is quite easy if you are thinking about it. And let us take the left hand side LHS. Sin to the power of 4a minus cos to the power of 4a. I am taking the left hand side. See, we don't have any formula like sin to the power of 4a minus cos to the power of 4a. We don't have any formula. So what we can write for this means, we can also write sin square a whole square minus cos square a whole square. We can write like this. Because it's again come back to sin to the power of 4a only. Sin square a whole square minus cos square a whole square. Once if you write, immediately you have to think about the algebraic identity. A square minus b square. We need to observe that identity. A square minus b square. That identity you should be remembering. It is a plus b into a minus b. This identity is very important. A plus b into a minus b. We need to use this identity in this problem. That's what I'm telling. Trigonometry is not just using trigonometrical identities. We should also use algebraic identity also. So let us, sin square a is nothing but a. Cos square a is nothing but b. That is very important to understand. So let us use that. So a plus b means sin square a plus cos square a. That is a plus b. A plus b means sin square a plus cos square a. A minus b means sin square a minus cos square a. So that is very important for you to understand. A plus b means sin square a plus cos square a. A minus b means sin square a minus cos square a. That's a very important thing you should understand here. So sin square a plus cos square a. What is sin square a plus cos square a? It is nothing but 1. You should know the identity very well. So that is nothing but 1 we'll write here. And you must be knowing this. We'll write as it is this one. Sin square a minus cos square a. We'll write as it is. That is equal to, again when you observe sin square a minus cos square a, we don't have any formula. We cannot write again a plus b into a minus b. It's not correct it is, because we need to prove 2 sin square a minus 1. We should always keep on seeing the RHS also while taking the LHS. So sin square a is there, so sin square a should be there, but cos square a is not there in RHS. So we have to remove the cos square a. So what should you write for cos square a is a very important question. See, cos square a is also equal to 1 minus sin square a. Students, you should know this very well. Cos square a is nothing but 1 minus sin square a. We have to substitute here in the place of cos square a. Sin square a will write as it is minus, in the place of cos square a will write as 1 minus sin square a. That's very important step, children. You need to understand. Cos square as 1 minus sin square a. So now we open the bracket. So sin square a will write as it is, minus into plus, minus 1, minus into minus, plus sin square a. So you can observe sin square a plus sin square a. Sin square a plus sin square a is 2 sin square a minus 1 as it is. So that is nothing but RHS. You can see very clearly it is nothing but RHS. So it's so easy to prove the sum, that is LHS is equal to RHS. So hence we have proved it with simple steps by using a square minus b square formula, and then we are using sin square a plus cos square as 1, and then we use the third identity is 1 minus sin square. That's nothing but cos square is 1 minus sin square. So when you are proving this, you should always see the left hand side as well as right hand side, and then keep on solving the sums. It's very important to observe. Thinking is very important, children. So 1 minus tan a whole square plus 1 plus tan a whole square is equal to 2 secant square. So this problem also, when you observe very carefully, all of you children, you need to observe very carefully this, because something says here, whenever a sum you get, you please observe, because in board exam also they give 15 minutes for reading time. In that reading time you have to observe these problems carefully. So what we need to apply is a very important. You can see very clearly it's a formula. We can use the algebraic identity first. That is a plus b whole square plus a minus b whole square is equal to 2 into a square plus b square. So this is what the formula you are going to use for this problem. So you can observe, because it is a minus b whole square plus a plus b whole square, same thing as a plus b whole square plus a minus b whole square. It's both are same only. So let us take a left hand side, LHS 1 minus tan a whole square plus 1 plus tan a whole square. This is a left hand side I am taking. You can see very clearly we need to use that identity a plus b whole square. Here a is 1 here and b is tan a. Children, I think you should be knowing this very well clearly, because this is an algebraic identity you need to observe. So that is equal to 2 into a square. Here a square is 1. 1 square plus b square. B means tan a. It is tan square a. Tan square a. So that is equal to. So again we need to come back to know about the trigonometrical identity. That is 1 square is 1 only. 1 plus tan square a. 1 plus tan square a is secant square a. That you should know very well. 2 into secant square a. So that is nothing but RHS. That's nothing but RHS. You can see LHS, therefore LHS is equal to RHS. So we have proved it so easily by knowing the what you call as algebraic identity and by knowing the trigonometric identity. The two concepts. The two concepts, if you are clear, the problem is so easy to get. You can easily get 3 marks. So this is the 3 marks problem it is. If it comes in board exams, it comes for 3 marks. So children, you have to be very clear about this. So after knowing about this, let us move on for the next problem here. This is also when you observe, all of you children, please observe the question very carefully. Don't solve the sums mechanically. That's what I would like to say, children, to be very careful while solving the sums. Secant square a plus cosec square a equal to secant square a into cosec square a. It's not dot, it is into, it's a multiplication into cosec square a. So let us take the left hand side and prove the right hand side. Always I feel that left hand side is quite easy, means you can take it and do it off. So here let me take the left hand side here. LHS secant square a plus cosec square a. This is the left hand side I am taken here, and we need to prove secant square a into cosec square a. See, we don't have any options like secant square a plus cosec square a. We don't have anything like identity. So secant square a we can write as 1 by cos square a. So this is very important, children should know very well. It's actually called as a reciprocal relation of secant. Secant is 1 by cos a. Here, since it is secant square a, we will write as 1 by cos square a. Again, plus in the place of cosec square a, it is reciprocal relation for cosec square a is 1 by sin square a. So this is a very important thing you should know, children, very well. So cosec square a is 1 by sin square a. So we have used a reciprocal relations for this. Secant square is 1 by cos square a, cosec square is 1 by sin square a. So as usual, what you should do, children, it is plus sign is there, we should take LCM. So what is the LCM here? Cos square a into sin square a. Children, you should know very well about this. This is the LCM part you should take very clearly, and don't make any mistakes in the LCM, children. Be very careful. Sin square a into 1 is sin square a. That's the LCM concept. Plus cos square a into 1 is cos square a. I am not doing cross multiplication, children. Please be very careful. It's the LCM concept it is. So that is equal to, again, children, you have to be very clear about the identity. We have to come back to the first identity. Sin square a plus cos square a is 1. Sin square a plus cos square a is 1. 1 by cos square a into sin square a. So that is a very, very important thing we should learn, children. 1 is sin square a plus cos square a is 1, and the denominator we are writing as it is. And this can also be split like 1 by cos square a into 1 by sin square a. Both are same only. What we written, the same thing I am writing here, but I just written splitting. 1 by cos square a into 1 by sin square a. What is 1 by cos square a? 1 by cos square a is secant square a. Just now I explained you that It's a reciprocal relation. 1 by sine square A is cosec square A. So you got the RHS. That's the right hand side, RHS. So we have proved that LHS equal to RHS. So hence we have proved it. Such a simple concept it is, children. So you should know the concept is here reciprocal relations and one identity, sine square A plus cos square is 1. So these two important concepts we used and we have got LHS equal to RHS. I hope it is clear, children. So cosec A plus sin A into cosec A minus sin A is equal to cot square A plus cos square A. Cot square A plus cos square A plus. So this is one of the problem where when you observe it, no, I think all of you should be very clear now, because once if you see the sum itself, cosec A plus sin A into cosec A minus sin A. Immediately I think you will respond because you already done A plus B into A minus B. So it is nothing but cosec square A minus sin square A. We are using the algebraic identity, that is just now we have written in the previous sum, that is A plus B into A minus B. It is nothing but A square minus B square. We are using this algebraic identity here. Here A is cosec A and B is sin A. So A plus B into A minus B is A square minus B square. So we are using directly cosec square minus sin square. That's the first idea we will get, all of you will get, because we know the algebraic identity also. After this, we should be observing very carefully what we need to prove the right hand side. That is, so cosec square A minus sin square A we are getting. After A plus B into A minus B apply cosec square A minus sin square A. So when if you see the RHS, it is cot square A plus cos square A. Here we need to think about cosec square A, what we can write in terms of cot square A. So children, you must be knowing very well 1 plus cot square A is equal to cosec square A. This is what you people have to be very clear about this. 1 plus cot square A equal to cosec square A. So what is cosec square A here? We can write this cosec square A as 1 plus cot square A. 1 plus cot square A minus sin square A, children. That is what you should know, because in RHS it is cot square A. I also have to bring in terms of cot only. Now we have to be very careful. So what we have to arrange the terms, rearranging the terms. Rearranging the terms means cot square A we already got it. We can write this as plus 1 minus sin square A. 1 minus sin square A. I'll just bring this 1 minus sin square A together, because 1 minus sin square A. What is 1 minus sin square A? It is cos square A. That is again the identity. Cot square A plus cos square A, because 1 minus sin square A is cos square A. That also you learned in the identity. Very important that you people should be remembering this. So that is equal to RHS. So we have proved LHS equal to RHS. So hence we have proved this. So very simple it is, but only we have used A plus B into A minus B is A square minus B square. Then we have written cosec square as 1 plus cot square A. Then we have written cot square A as it is, and then we have rearranged 1 minus sin square. 1 minus sin square is cos square A. So hence we have proved LHS equal to RHS, children.